There's a number on your phone right now that is lying to you. Not the battery percentage, the clock. Physicists have quietly stopped agreeing that it means what you think it means. Somewhere in an equation meant to describe the entire universe, the variable for time simply does not appear. Not hidden, not disguised, absent. And when scientists first saw that equation, some of them didn't celebrate. They panicked. Because if that equation is right, then the moment you're living right now already happened. And it will always be happening. Forever. Let me show you the graph that broke their certainty. Most people assume time is the one thing in the universe you can trust. It ticks, it moves forward, it never lies. You wake up, the sun rises, your coffee gets cold, your phone buzzes with a new notification, and somewhere underneath all of it, a silent clock keeps perfect, honest count. That feeling is so deeply wired into us that questioning it feels almost insane. But here's the problem. Nobody talks about it at the dinner table. The version of time you experience, the flowing river version, the past behind you and the future ahead of you version, is not the version that shows up in the deepest equations of physics. And that gap between what we feel and what the math says has been widening for over a century. Let's start with the graph, because this is where the crack first appears. Picture two dots on a flat sheet of paper, one representing an event happening on Earth, the other representing an event happening on a spaceship, moving at a significant fraction of the speed of light. Draw a line connecting them across space and across time. Now here is the part that should unsettle you. Depending on how fast you're moving relative to those two events, the order in which they occur can flip, not the timing, the order. What looks like event A happening before event B to someone standing still can look like event B happening before event A to someone moving fast enough. This isn't speculation. This isn't a thought experiment dreamed up to sound clever. This is called the relativity of simultaneity, and it is one of the most rigorously tested predictions in the history of science. Think about what that actually means for a second. If two people can genuinely, physically disagree about which event came first, then now cannot be a universal fact. There is no cosmic master clock ticking the same beat for everyone everywhere. Your now and my now are not the same slice of reality unless we're standing in the exact same place, moving at the exact same speed. And once you accept that, the floor starts to shift under a belief you've held since childhood. But here's where it gets worse. This isn't just theoretical elegance sitting in a textbook. It's operational. Right now, above your head, satellites are orbiting the planet running atomic clocks that have to be corrected daily because time genuinely moves at a different rate for them than it does for you, standing on the ground. Faster moving clocks in orbit and clocks sitting in a weaker gravitational field tick at a measurably different pace than clocks fixed to the Earth's surface. If engineers didn't calculate for this, the GPS in your pocket would drift off by several kilometers within a single day. Read that? Again, the navigation system guiding your car right now only works because scientists accept that time is not one single uniform thing flowing at one single uniform speed. It bends, it stretches, it slows down near mass and speeds up in empty space. So if time isn't a universal river, what is it? This is where physicists started drawing a very different kind of graph, one that changed everything. Instead of treating time as something separate from space, something that flows through a static three-dimensional stage, Einstein's framework merges space and time into a single four-dimensional structure. Physicists call it space-time. And when you plot the entire history of the universe onto that structure, past, present, and future, stop looking like a sequence. They start looking like a shape, a fixed, unmoving four-dimensional shape, sometimes called the block universe. Sit with that phrase for a second, because it is not a metaphor. In this model, the moment you were born, the moment you're reading this sentence, and the moment you will eventually die are not fundamentally different from each other. They are simply different. Coordinates within the same unchanging block. The same way New York and Tokyo are simply different coordinates within the same unchanging map. Nothing is happening in the block universe the way you think it is. Nothing is arriving. Nothing is passing. Every event that has ever occurred and every event that ever will occur is already there, baked permanently into the structure of reality, the same way every page of a novel already exists inside the closed book, whether you've read them yet or not. This is not chaos. This is structure. But it's structure that erases something you have never questioned. It erases the idea that the present moment is special. In this view, there is no cosmic spotlight illuminating now while the past sits in darkness and the future waits off stage. Every moment is equally real, equally solid, equally permanent. According to a growing number of physicists working in general relativity, our sense that only the present is real, that the past is gone and the future doesn't exist yet, might be one of the most convincing illusions the human brain has ever produced. And here's where the story escalates again, because the block universe wasn't even the deepest crack. it was just the first one. The real detonation happened when physicists tried to merge two of their most successful theories, quantum mechanics and general relativity, into a single framework capable of describing gravity at the quantum level. What they got back is called the Wheeler-DeWitt equation. And when they solved it, they found something that should not have been possible. The variable representing time had vanished from the equation entirely. Not simplified, not folded into something else. Gone. Think about what that means. This equation was supposed to be one of the most fundamental descriptions of reality that physics has ever attempted, a single formula meant to capture how the entire universe behaves at its most basic level. And according to that formula, the universe doesn't evolve at all. It doesn't move from one state to the next. It simply is, all at once, forever, with no past feeding into a present and no present feeding into a future. Some physicists have described this as the universe being fundamentally frozen, and that word frozen should sit uncomfortably with you because it directly contradicts everything you experience with your own senses every single day. This is where most explanations stop, because this is where things get genuinely uncomfortable. If the deepest equation we have for reality contains no time, then why do you feel time so intensely? Why does grief fade? Why does anticipation build? Why does your childhood feel like it happened to a different person entirely? The answer that's emerging from modern physics is stranger than fiction, and it comes from an unexpected place: heat. In the 1800s, long before anyone dreamed of relativity or quantum gravity, physicists studying steam engines discovered something called entropy, a measure of disorder in a system. And they discovered a rule that has never once been broken in the observable universe. Entropy always increases. Ice cubes melt into puddles, they don't spontaneously reform. Smoke disperses into the air, it doesn't gather itself back into a fire. Eggs break, they don't unbreak. This one-directional slide from order into disorder is called the arrow of time. And here's the twist that changes the entire conversation. At the microscopic level, the fundamental laws of physics governing individual particles do not actually require this one-way direction. Run the equations for a single particle collision backward, and they work exactly as well as running them forward. The universal preference for forward only shows up when you're dealing with enormous numbers of particles trending toward disorder. Read that again, because it's the key to everything. The arrow of time you feel every single day, the unmistakable sense that yesterday is gone and tomorrow hasn't happened yet, may not be a fundamental feature of reality at all. It may be a side effect of entropy, a statistical tendency emerging from an almost unimaginably ordered starting point at the birth of the universe. According to this line of thinking, time's arrow isn't written into the laws of physics themselves. It's written into the specific low entropy conditions the universe happened to start with. This is where the story takes an even stranger turn, one that's been gaining serious traction in recent physics discussions. Some theoretical physicists have proposed something called the thermal time hypothesis, the idea that what we experience as the flow of time is not a property of the universe at all, but a property of our own limited perspective within it. Under this framework, time doesn't flow through reality. Time emerges from the fact that we, as observers made of matter embedded inside the system we're trying to measure, can only ever access partial information about the universe's true state. Our psychological sense of flow might be less like watching a river and more like watching a puzzle slowly reveal itself to a solver who can only see one piece at a time, even though the completed puzzle has existed, whole and finished from the very beginning. Now here's the part that most people never hear, because it complicates the tidy, viral version of this story. Not everyone in physics accepts the block universe as the final answer, and this disagreement has actually intensified recently. In 2026, philosophers examining the foundations of relativity pushed back hard against the assumption that space-time is a single frozen block, arguing that physicists may have been quietly blurring the line between two very different concepts, things that simply exist and things that actually occur. Their argument is that treating every moment as equally existing doesn't automatically prove that nothing is truly happening, and that popular science may have oversold the block universe as settled fact when it remains, at its core, an interpretation rather than a proven conclusion. Some physicists working directly in relativity have gone further, arguing that time may genuinely pass even in a universe where nothing physically changes, and that the growing trend of eliminating time from fundamental physics deserves far more scrutiny than it's currently receiving. And this is where everything changes again, because this isn't a settled debate with one side quietly winning. But there's an entire competing model called the evolving or growing block universe, championed by cosmologists including George Ellis and Bernard Carr, which tries to have it both ways. In this version, the past and present are locked in, fixed, unchangeable, exactly like the traditional block universe describes. But the future is genuinely open, not yet written, not yet real. existing only as probability until the present moment crystallizes it into fact. In this model, there is a real, objective now, a genuine boundary where quantum uncertainty collapses into classical certainty, moving forward and adding new fixed pages to the block as reality itself is generated in real time. It's a direct attempt to rescue the intuitive feeling that the future is undecided, that your next choice actually matters, without throwing away everything relativity has taught us about the flexibility of time. So which version is correct? The frozen, fully deterministic block where your entire life, from first breath to last, already exists, complete and unchanging? Or the growing block, where the past is locked forever, but the future remains genuinely, meaningfully open? Here's the uncomfortable truth most confident explainer videos won't tell you. Nobody currently knows. What most people are not seeing is that this isn't a solved mystery being simplified for a general audience. It's an active, unresolved argument happening right now among people who have spent their entire careers studying exactly this question, and the disagreement is not shrinking, it's sharpening. Think about what's actually at stake in this argument, because it reaches far beyond physics classrooms. If the fully frozen block universe is correct, then in some very real sense, free will, as you understand it, becomes an illusion. Every decision you believe you are making in this exact moment would already be a fixed coordinate in a four-dimensional structure that has existed, unchanging, since the beginning of the universe. You wouldn't be choosing your next action. You would simply be experiencing a moment that was always, eternally, already there. Every argument you'll have next year, every apology you'll offer, every risk you'll take, already exists, sitting quietly in the block, waiting for your consciousness to arrive at that coordinate the way a train arrives at a station that was built long before it left the last one. But if the growing block universe is correct instead, something very different is true. Your choices genuinely matter because the future genuinely doesn't exist yet in any form. It isn't fixed. It isn't waiting. It is being generated moment by moment, and your decisions are part of what determines which possibilities collapse into permanent, unchangeable fact. In this version, when a moment becomes now, it becomes real forever, but it wasn't real a moment before that. This is not a small philosophical footnote. This is the difference between a universe where your life is a script you're reading and a universe where your life is a script you're still writing. And this is where the story reaches back into something deeply personal, something that most people watching don't expect a physics explanation to touch. If any version of the block universe is even partially correct, then in a strange and genuinely comforting sense, the people you've lost are not simply gone. Under eternalism, every moment they were alive still exists, permanently, unshakably, somewhere in the structure of space-time. Not as a memory, not as a photograph, as a real, physically existing coordinate in the four-dimensional shape of the universe, exactly as real as the moment you're reading this sentence right now. Their laughter at a birthday party years ago hasn't faded into nothing. In this framework, it's still happening, permanently, on its own page of the block, forever. But here's the darker mirror side of that same idea, and it's the part almost nobody says out loud. If the past is permanently real, so is every painful moment, every mistake, every version of you that you've since outgrown still exists, unchangeable, on its own fixed coordinate, forever. Nothing gets erased, nothing gets forgiven by the structure of the universe itself. It simply sits there, permanently true, the same way the joy sits there permanently true. In the block universe, redemption doesn't rewrite your past self. It just adds a new, equally permanent coordinate further along the structure, existing alongside the old one, not replacing it. This is where the deepest implication finally surfaces, the one that connects all the way back to the graph we started with. If time is genuinely a structure rather than a flow, then the version of you reading this sentence right now at this exact instant has, in some physical sense, always existed and will always exist, permanently fixed at this precise coordinate in space-time. You are not passing through this moment. According to this model, you are this moment eternally, the same way a specific city is eternally located at a specific set of coordinates on a map, whether or not anyone is currently looking at that part of the map. So where does that leave us? What most explanations conveniently leave out is that physics has not actually answered the question in its title. It has only sharpened it. We know with extraordinary experimental confidence that time is not the uniform, universal river Newton imagined. We know clocks disagree, order can flip depending on your speed, and the deepest equation attempting to describe reality contains no time variable at all. We also know that a serious, active, growing body of scientific and philosophical work is pushing back against the idea that this means time doesn't exist, arguing instead that physicists may be mistaking a mathematical convenience for a metaphysical truth. The block universe might be the final word on the nature of reality, Or it might be, as one recent philosophical critique put it, closer to poetry than to settled science, a beautiful interpretation that has not yet been and may never be definitively proven. What we're left with is not an answer. It's a genuinely open question sitting at the exact intersection of physics, philosophy, and the private, uncomfortable experience of watching your own life unfold one moment at a time. Is the future truly open, waiting to be written by choices that haven't happened yet? Or has it already been written in full, and you are simply arriving at pages that were always there, reading them for what only feels like the first time? Every physicist chasing this question is essentially staring at the same graph, the same block, the same silent equation with no time variable, and drawing different conclusions from it. And maybe that's the most unsettling part of all. The clock on your wall, the one you trust without question, the one that seems to prove time is real, flowing, and universal, might be measuring something far stranger than ticking seconds. It might be measuring entropy. It might be measuring your own limited perspective inside a structure that has no true flow at all. Or it might, despite everything modern theoretical physics has thrown at it, simply be measuring time exactly the way you've always believed. Nobody currently knows which of these is true. And somewhere, right now, in laboratories and universities and quiet offices full of chalkboards, that argument is still happening, unresolved, unfinished, exactly like the future everyone in that argument is still waiting to see.